Okay, in today's video, we're going to uh, program into Promodel the next activity. Let's say that entities arrive at a line with a capacity of 5, following a uniform distribution with an average of 7 and a standard deviation of 2 minutes. They arrive to a line with a capacity of 5. If they can enter the line, they exit the process. After waiting in line to be attended by one of 3 servers, they get their attention with a uniform distribution with an average of 8 and a standard deviation of 1 minute. Finishing this process, they divide into 2 groups. One group goes to a line with a capacity of 7 spaces that will represent the 50% of the entities that already had finished process number 1. The rest, or the 45%, go to a line with a capacity of 3. In either of those 2 lines, they wait to be attended by one server that attends them with a uniform distribution with an average of zero point 0.3 and a standard deviation of 0.05 minutes. After finish process number 2, they divide into 2 different lines, 50% and 50% for each of those lines. Those lines have an infinite capacity. They wait in line to be attended by one of 2 servers that attend them following a uniform distribution with an average of 2 and a standard deviation of 0.5 minutes. After finishing that process, they exit. Okay, this is the description of the problem. So now we're going to go to Promodel to start with the programming of this. We're going to start by choosing in the building menu locations, and then we are going to choose for lines. We are going to use this icon right here that it is a palette, and for the processes we are going to use the image or the icon of the worker. So I just have to click one time in the graphic section and then another time in the layout version. It is very small, so I just make it a little bit bigger. And in the table, we have our palette that I'm going to change its name from palette to line 1. And as it has a capacity of 5, if I don't recall, yeah, it's okay. It's a capacity of 5. Then I'm going to put another location using this icon of worker, and I'm going to call it process 1. And as there are 3 different servers, I'm going to use a capacity of 3. After finishing process 1, they divide into 55% and 45% to 2 different lines. I choose again 2 palettes. I change their name, the first one into from palette to line 2, the third one from palette into line 3. Then they go to process 2, but before that, I'm going to change the capacity of the lines. Line 2 has a capacity of 7, and line 3 has a capacity of 3. We can check that out in the image. And yeah, this line has a capacity of 7, and this line has a capacity of 3. Okay? And process 2 has a capacity of 1. And I'm going to change the first one from process to process 1. Okay? So now I need 2 more lines, both with infinite capacity. And I'm going to call them line 4 and line 5. And now we need the third process that has a capacity of, okay, it's process 3 that has a capacity of 2. And line 4 and line 5 has an infinite capacity, INF, or infinite if you want. Okay, so we have the whole layout. I'm just going to move a little bit the images. So clients arrive at this palette, then they go to process number 1. After that, they go to one of those 2 lines. They wait to be attended by process number 2. After finishing process number 2, they go to another 2 lines, and they wait for one of 2 servers to get attended, and then they exit the process. Okay, so this is the building of the location, the spaces where the process take place. Now we return to the building menu, and now we choose entities. And I'm going to choose the other icon of worker, the one that it's a female. I increase its height to make it more visible. And I'm going to change the name from worker into client. Okay, and that's all I'm going to modify in the building of the entities. Now we return to the building menu and we choose arrivals. And then we choose an entity called client. We tell them that it arrives to line 1. The quantity each or per arrival is going to be 1, as client arrive 1 at a time. Its first time it's going to be 0, and it's 0 because we are telling the software to start the arrival process when the simulation starts. If I were to put any information here like 10, it will wait 10 hours before the first arrival. So I'm going to type again 0 for the arrival process to start at the beginning of the simulation. Occurrences, it's how many times do you want the process of arrival to take place, and we are going to tell the software that we want infinite occurrences. That means that as long as the simulation is running, there's going to be arrivals. Frequency, it's going to be the probabilistic behavior of the arrival process. And as we can see in this image, the arrival is a uniform distribution with an average of 7 and a standard deviation of 2 minutes. So in frequency, we type U for uniform and then 7,2 and minutes. No logic and no disable of this process. Okay, so this is the arrival. We choose the entity client that it's going to arrive to line 1, that it's this palette right here. They arrive, the clients arrive 1 at a time at the beginning of the process with infinite occurrences as long as the simulation takes place, with a frequency of 7,2 minutes, uniform distribution. Okay, so now we are going to start with the process. And we have 2 different windows, one for process, one for routing. And we are going to tell in the process window where the entity is, and in routing where the entity is going. Okay, also we tell the entity in process the operation that it takes place in that location. Okay, so we're going to start. Client arrived at line 1. It doesn't perform any operation because it is just waiting in line, but it goes, and it's really important to choose the same entity and the process and in the and routing. And the destiny is to process one, and the rule is first available. First available means that in when the one of the three servers is ready, they are going to go to that place. And I will accept this, and I'm going to stop a little the process because I want to show you how we can use resources in this process. These resources can be people, can be machines, it can be tools. In this occasion, we are going to use people. So not only as an image, but as a resource. So I'm going to return to the build menu, and I'm going to choose resources. I'm going to choose the same icon, and I'm going to say that the first one is called servers one, servers one for process one, and there are three servers. I'm going to create another resource called server 2, that is the one that attends process 2, and one last resource that I'm going to call servers 3. And we have two of those. So we have, in that location, we have 3 spaces, and the servers are 3 to occupy one of those spaces to attend one of those of the clients that are waiting in line. In process 2, we just have 1 space and we have 1 resource. And in process 3, we have 2 spaces and we have 2 resources. For this program, for this occasion, it is the same to use or do not use the resources, but I just want to show you how we can use resources. Okay, in this occasion, they're not it's not an obligation to program the resources, so we're just going to use them for next time you know how to use them. Okay, so we're going to continue with the process. So I return to the build menu. I choose process. I already programmed that client is in line 1, and then it goes to process number 1. And this red arrow right here, the program just put it as we program the commands here. Okay, so now the client is in process number 1. I return to process. I enter a new line just by entering that. Okay, so it is the entity client. Now it's in the process 1 location, and it does perform an operation right here. The first operation that it's going to do is getting the server. So as it is in process 1, it's going to get servers 1. It's going to get one of those 3 servers. Then it's going to wait a uniform time of, if I remember correctly, it's 8,1 minutes, a uniform time with an average of 8 and a standard deviation of 1. And the last instruction is free the servers. So they get 1 server, the entity gets 1 server, get its attention, and then as it finishes its attention, it frees the server. Let me just check in the image of the problem if that was correct. Okay, it's correct, 8,1 minutes. Average of 8 and standard deviation of 1. Okay, and there's a little button here that says compile. I'm going to use it. I'm going to press it. just to know that it is successfully compiled. This means that the software understands the operation. Okay, so this is the process. In process number one, gets to the server, waits 8,1 minutes with uniform distribution, and it trees the servers. And in routing, the client, it's going two ways. It can either go on line 2 or line 3, but not with first available rule, but a probability rule. And as 55% go to line 2, I type probability 0.55. Okay, and in routing, I open a new line by entering. I choose client again, and now I program the rest, the 45% of probability. Okay, so now we have clients in line 2 and in line 3. And I have one process and two routings. Okay, one process and 1 and 2 routes. So now I return to the process window. I choose the client entity. Now I program the ones that are in line 2. They don't perform any operation. They're just waiting in line. And they go from line 2, the same client, into process number 2 as a first available rule. And now I'm going to program the clients that are in line 3. They do just the same. They wait in line and they go to process number 2. Okay, as first available rule. Okay, so now clients are in process number 2. We enter a new line in process. We choose the entity. We choose process 2 as location. And in operations, they are doing a very similar programming just as process number 1. So first of all, they get server 2. They wait. This time it's also a uniform distribution, but it's 0.3, 0.05 minutes, and they free server 2. You can choose them from the software. So I compile this. It is successful. So now I program the routing from process 2. From process 2, the client goes to line 4 or line 5 with a probability rule of 50%. So 0.5 for one route. And in routing, I open a new line. I choose again client, but now it goes to line 5 with a probability of 0.5. Okay. So now clients are some on line 4 and some on line 5 waiting to be attended by process number 3. So I go to process. I open a new line. I choose client again. Now they are on line 4. They doesn't perform any operation and they just go to process number 3 with first available rule. Then the clients that are in line 5, they wait there, and when one of the two servers of process 3 are ready, they go there following a first available rule. And for the last operation, the client is in process 3 location, and the operation is they get servers 3 as they are in process 3. They wait uniform time, let me see the image, of 2,0.5 minutes. 2 as an average and 0.5 minutes as a standard deviation. Okay, And after finishing the process, they free servers 3. Okay, we compile this. If it's successful, and the unrouting after finishing process 3, they just exit the process. If you notice, the software already programmed the exit. You don't need to program exit as allocation. And the rule is first available. So this is it for the process that it's represented in this image right here. So now we are going to program the simulation options. We go to the menu and we choose simulation, options, and then we type here the amount of hours that we want to run. It says here, it's in Spanish, but it says here that otherwise, if you don't change the unit, it's going to be hours, the default unit. So I'm going to run it for 120 hours. I'm going to accept this. Let me see if I did that correctly. 120, okay, we accept. I'm going to save this program. I'm going to name it activity 3. Going to save it in the desktop. So I save it. And we run it and we hope that it's okay. So it's running. We are observing how the clients are being attended. They pass real fast from process 2. We were not able to identify that, but we are seeing that they are getting a little bit stuck on process 1 and on process 3. In this bar right here, we can accelerate the process just by moving this bar to the right. So it finished at the 120 hours, and it asked me if I want to see a result. I do want to see them. And let's see how this process performs. First of all, it performs very well because, as you can see here, the client is always on operation. This green means in operation. What we don't want to see here is this pink color. That will mean that it's waiting. We had 1,025 exits. We attended 1,025 clients in 120 hours. The operation time is 10.32 minutes, and the amount of time in the system, it's 10.32 minutes. So it's not waiting any second. So we have a very efficient process. We can see this in the resources states. Servers from process 1, as an average, they are being used 38% of their time. Server 2, it's used only 4.27%. And server 3, it's used, the server 3, this is the individual percentage. The average percentage is 14.29%. Okay, so the process is very good. We have a lot of free time from the operators. Maybe we can change them. We can take off some of them. But what we are going to do, I'm going to show you another thing right here. And we are going to program downtimes. Downtimes will mean that in this case, we are giving the servers time off. Okay, and we are going to see how the process works. Okay, and for that, we are going to the building menu. We're going to choose locations. Not locations, excuse me. I was talking about resources. So we're choosing resources, and we are choosing these, the downtimes, and we are programming Just I'm going to choose server 2, the one that has the most time in usage, and we are going to program those downtimes by clock. Frequency, we are going to tell them that every 2 hours, every 120 minutes, it's going to have a pause. First time, 120 minutes, so the program waits 2 hours. Priority, 0.99. Logic, we are going to tell the resource to wait 15 minutes. Every 2 hours, I'm going to give them 15 minutes just to see what happens. Okay. Okay. Very good. And now I'm going to locations, and we are going to program a downtime, but I'm going to program a downtime for the lines. Let's see what happens if one of the lines is not available for some amount of time. Let's say line number 2 and 3. Okay, by clock. And we're going to tell them that every 4 hours, 240 minutes, every 240 minutes with the first time of 240 minutes. Let's say that we will clean the line, okay? So the logic is going to be, and for cleaning the line, we need the one of the server, and we are going to use server 2, and he is going to take 30 minutes of time to clean the line every 4 hours, and then we're going to free it. Remember that server 2 only worked 4.27% of its time. Okay, so it's successfully compiled. And what else can we do? Let's say that process number 2 is going to have, oh, not 2. Let's say that process number 3. Process 2. Here, process 3 with a frequency of every 3 hours, 180 minutes. First time 180 minutes. The logic is going to be get servers 3, then they are going to wait 45 minutes, and then they are going to free, servers 3. Okay, so we compile it. So let's see if it if this process is as efficient, or it's going to have a lot of problems this time. So I'm going to save this, and let's run it and see what happens. Okay. So now client is waiting, not only waiting, but it's blocked. This is not good. The exits are not as bad as they were. They are almost the same, but the time that it takes in the system, it's 20 minutes, twice as much, almost twice as much. And the operation time, it's almost the same because we didn't change that part. The servers work a little more, but as you see, server number 2, now it is being used 16% of the time. So maybe we can use server 3 to do the work of server 2 and see what happens. But that will be in another video. So in this video, we learned how to program in Promodel and how to program downtimes, errors, or just some time off from the line for the workers. Okay, so this will be it for this video. So thank you very much. I hope you enjoy this. Bye bye.